Hello, sir.
Yes, it's Tidiso.
Yes,
How are you?
I'm fine, and how are you, sir?
Yeah, I'm fine. Yes, I was still busy talking to the management there. I don't know whether the new teacher has arrived or what.
We currently don't have a physics teacher. I don't think we're gonna get one.
Yeah, you must tell others, grade 10, 11, and 12, if they need help in the meantime, they may join the group online. Then
Yeah.
we see how it works. If you see that it's going to work with you, then we can continue like that. So first, these are trial. You see if it's going to work. If it does not, then it's not a must. You feel whatever that you feel comfortable with. So let's try it. We see how we're going to engage. Then you give us feedback. I'm just waiting for the other learner to join. This other learner I'm waiting. So just be patient. We'll start very soon.
Okay.
Is the screen sharing now?
Yeah.
Okay. Let's start. If he joins, you just let me know, then I will accept him. So once you see that someone wants to join, just let me know, then I will let him in. So for today, I know we're doing chemistry in class, but for today, let's just touch on these electric circuits. We see we'll be balancing physics, the other session, chemistry, the other section, so that we balance both sides.
Yeah.
All right, so let's start with this circuit. You can also try it. You can just draw it in your notebook here and there. Then we try analyzing it, or you can take a screenshot. Then you write it down. You can work it whatever way. So in an electric circuit shown below, the battery has an EMF of 6 volts and an internal resistance of 1 ohm. The total external resistance of the circuit is 9 ohms. So first here, when you are given this situation, you must have your formulas, but normally you are given at the back of the formula of the question paper, there is a formula sheet. So whenever they talk of EMF, the formula that must come into your mind, which you are going to use, it's E for EMF, which is EMF is equals to I, which is current for the whole circuit. So it will be I bracket R, which is R for the whole circuit, the total resistance for the whole circuit, plus the R, small r, which means it's the internal what? Resistance. So internal resistance is represented by the small letter R. The external resistance is represented by the capital letter what? R. Can you see? Yes. So the internal resistance is R, which is the small letter R. So in our case, now we have to substitute and then you solve for what you know. So the EMF we are given, it's 6 watt volts. Okay. So in other words, where there is EMF, we are going to put 6 is equals to, what is the current? We are not given yet. Current, that is your I. Bracket, what is your the external resistance? We have been told that the total external resistance of the circuit is what?
It's 9 ohms.
9 ohms. So you write your 9. So it will be 9 plus. What is the internal resistance R?
Plus 1.
Plus 1. Yes. So which means in this situation, I can be in a position to find for what? To solve for I. So let's solve using mathematics, which means we are going to say 6 is equals to the current, which is I, multiplied by what? 9 plus 1 gives us 10, isn't it?
Yes.
So if you want to make I subject of the formula, which means I'm going to divide both sides by 10, which means on my right-hand side, I'm going to divide the right-hand side by 10, so that I'll be left with I. So here I divide by 10. This side I divide also by what? By 10. Yeah. So that 6 over 10 is equals to my current. The 10 and the 10, the current, they cancel out. So you'll be left with I is equals to 6 divided by 10, which is 0, what? 6. But the units, what is the unit for current? The units for current? Which symbol are you going to put there? The unit for current?
Yes.
Amperes, yes.
Yes, yes.
Yes, that is the unit for current. That's the unit for current. That's the unit for current. Any question there?
Oh, I understood it.
Yeah. That is the, but the question here is saying calculate the current in R1 when when the switch is closed. So calculate the current in R1 when the switch is closed. So here you are seeing that the switch is what? Is open.
Yeah.
So we are saying here, when the switch is closed, now the switch is what? It's open. So which means it's an open switch. By open switch, that is no current is flowing. So the switch is open. This is the open switch which they are having here. So when it's closed, which means the line now changes. It's now straight. There is flow. When the switch is closed, current starts to flow. When the switch is closed. That's what it means. So now when it flows, and current starts to flow from the positive, moving towards the negative side. So this is the positive. The long terminal is the positive side. The shorter one is the negative what? Side. That is the long side. Yes. The long side is the positive. The shorter side is the negative. Always current starts to move from what? Which direction? From the positive. So which means our current is going to start flowing from the positive side, moving like this. So this is the I which you are referring to, which is coming into R1. Then the current comes here. When it reaches this point, we call it a junction or a node. Some current will flow here and some current will flow here, this direction, which means it's going to split. Once the current splits, it continues moving, which means it comes here. Some current flows here, it reaches another junction where it's going to join, which means this current will enter here, this current will enter here, then it joins up. So this current that is coming back, it's also I. Then it comes back to the circuit, which is, that's how current flows. So current flows always away from the positive towards the negative side. So in our question, it's saying calculate the current in R1, which means they are referring to current for the whole circuit, which we have already calculated, which was I, which is that I which we already calculated. So which means the answer which they are referring to, calculate the current in the circuit, I is 0.6 amperes, which means amps, that is the unit. Any question there?
No, sir. Okay.
Yeah. Let's go to number, we have calculated the current. Now we are going to the second one, 9.22. For 9.22, it's saying the power dissipated in resistor R1 is how many watts?
1.8 watts.
1.8 watts. The resistance of the resistor R3 is 4 times that of R1, R2. So the relationship there is that R3 is equals to 4 R2, which means which one is bigger? Which resistor is bigger there?
Oh, it's R2.
Between R3 and R2, which resistor is bigger?
So
If I'm to ask you, it's R3, because the resistance of R3 is 4 times, which means R3 is the biggest by 4 times. So the question is saying calculate the resistance of R1.
R2.
Yes. So first we must know the resistor of R1. So we are given R1, which is 1.8 watts. But what does power tell us? What is the formula for power? Power tells us what? What does power tell us? How do you calculate the formula for power? Power is how many watts? Power in R1, it's 1.8 watts. Yes. So if you want to know the current through R1, we know already it's 0.6 amps. We have calculated this current, which is flowing through what? R1. So using the power formula, we know power is the same as what? I squared R power, or V times current. There are two formulas for power. Power, you can get power by saying I squared multiplied by the resistance flowing through R1. That's what it means. Or I can say power is equals to voltage at R1 multiplied by the current flowing through what? R1. So these are the two formulas that you are going to use to find for power. But in this case, since you are looking for the resistance R1, the magnitude of the resistance R1, which means you are going to use this formula, which is above this one. Yeah. We are going to use this formula. We make R1 subject of the what? Of the formula, which means I'm going to divide both sides by I squared. So which means P divided by I squared, which is the current you square it, is equals to the magnitude of the resistance at R1. What is P? P is 1.8. What is current? Current is 0.6. So 1.8 divided by 0.6, what do you get? 5. 1.8 divided by 0.36. Because we have squared the denominator. Yes, we get 5 ohms.
5.
So now, yes, 5 ohms. Yeah, so now 5 is this resistance. Now we have calculated the magnitude of this resistance, which is 5 ohms. So now we know that here it's what? It's 5?
5 ohms. It's 5
ohms. Yes. But we were told that the total resistance of the external circuit, it was 9. So which means the parallel combination is having how many? The parallel combination is having 4 ohms. Because 5 is here. And then what is 9 minus 5? This is the total external resistance. It was 9. Oh. So what is 9 minus 5 is 4, which means the 4 ohms, it's here on the parallel combination, this parallel combination. Oh. That's where the 4 ohms is here. This must give us a total of 4 ohms. If I say the total resistance in the parallel combination, R2 plus R3, it must give me a sum of 4 what? Ohms. That's where it's coming from. So since now I know R1, now what's left is for me to find R what? R2 and R3.
R3.
Yes. But we know the ratio between R2 and R3. This is R3. So the ratio of R3 is to R2 ratio, R2. It means that how many times is R3 bigger than R2? We're given a ratio here to say R3 is four times bigger than R2. So, yes. So which means if it's 4 times bigger in terms of resistance, it means if this is 1 ohm, isn't it? This one has to be how many ohms?
It has to be 4 ohms.
Yes, it's going to be 4 ohms. If this is 1 ohm, this is going to be 4 ohms. That is what it means. That's how big it is, 4 times bigger. So in other words, the ratio which they are referring to here is 1:4, which means 4 times bigger. So now when we simplify it, it means 1:4 in terms of ratio. So the ratio between R1 and R2, if it's here, if this is 4 times bigger, which means the ratio is like this, 1:4. But we know the total combination of the parallel combination of that circuit is 4 ohms. So now it's a matter of distributing that 4 ohms amongst those 2 resistors. How is it going to be distributed? So let's distribute. First, you must get the total ratio, which is 4 plus 1. So when you are dealing with the ratio, you are going to deal with the ratio like this. We calculate the total ratio first. So the total ratio, you write the total ratio is equals to 4 plus 1, which is equals to 5. So if I want R3 is equals to 4/5 multiplied by the total of that ohms, which is supposed to be shared, it's 4 ohms. And also, if I want R2, I do the same for R2. If I want R2, you write your R2 is equals to 1/5 multiplied by the 4 ohms, which is going to be shared. And then you get an. So tell me, what are you going to get? If you punch in your calculator, what are you going to get for R2 and R3?
For
Calculate.
R2, I'm gonna get 2 ohms.
For R what?
For R2.
4 times 1 divided by 5. What is the answer?
8. Oh,
4
by
5. 4/5 is what?
For R3 is going to be 3,2.
3,2, excellent. 3,2 what? Ohms. And then R2?
It's going to be 0,8.
Excellent, 0,8 ohms. And then you can verify. If you multiply 0,8 times 4, are you not going to get 3,2?
Check 0,8 times 4. Yes.
What? 3,2. Which means it's 4 times what? Bigger. Can you see?
4 times bigger, yeah.
So if you add those 2 resistance, you are going to get a total of how many ohms? 4 ohms. You are going to add. These are the 4 ohms where it's coming from. It's coming from here. It's coming from here. But yes. These resistors are not in what? Are not in series. In series. They are not in what?
In series.
They are in what?
Parallel.
They are in parallel. So how do you add resistors in parallel first?
See.
Before we go this route, you need to know that resistors in parallel, if they were in series, then that route was going to be correct to say that this will be R1, to be R2, and then this one will be R3. If they were in what? In series like this. Can you see? This one will be R what? R3. But they are not in what? In series. They are in what? Parallel. Yes. So which means we must use the formula first for finding resistors in parallel, the sum of resistors in parallel, before we share the 4 ohms. So which means it's going to be 1 over Rp is equal to what? 1 over what? R what? R2 plus
R3.
1 over R2. Because these are the resistors in parallel. Okay?
Yes.
So if I know the size of R, the resistance in parallel, we said what is the total resistance of the parallel combination? So which means if I know the total resistance of the parallel combination, which I'm looking for, Rp, which is parallel combination, it's going to be, what is the relationship between R3 and R2? We said it's 4 times bigger, isn't it?
Yes.
So which means you come and say 1 over Rp of the parallel combination is equals to 1 over, since this is 4 times bigger, so it's going to be 4 what? 4 R2 plus 1 over R2. You see what is happening?
Yeah, I can see.
So in other words, you need to find the common factor of 4R2 and R2. So which means the common factor there is just 4R2, like that. Which means that R4R2 goes into R2 once, plus 1, it will be 1. Then plus R2 goes into 4R2, how many times? 4 times, which means plus 4 is equals to 1 over Rp, like that. Then you use the inverse, which means that we are referring to as 1 over Rp parallel is equals to 5 over 4R2.
Yeah.
Which means 4R2. When you cross multiplying, it will give you 4R2 is equals to 5Rp. So we want, so 4R2, you write 4 multiplied by resistor number 2, R2 is equals to 5 times, we are cross multiplying now. We are cross multiplying. So it will be 5 multiplied by Rp. 5 multiplied by Rp. So the resistance in parallel, we know it's what? It's 4 already, isn't it?
4 ohms.
Yes, 4 ohms. We know the total resistance in parallel. But what we don't know is the what? The R2. So we come and say R2 is equals to 5 times Rp, which is the resistance in parallel, divided by what? By 4.
By 4.
Okay. So what is the resistance in parallel? You're going to say it will be 5 times 4, which is 4 ohms. Total resistance in parallel was 4 ohms divided by 4. So the answer here was equals to how much?
5 ohms.
5 ohms. That is R2. But you know that R3 is 4 times what? Bigger than what? R2. So if you know R2, R3 you can calculate. R3 is going to be how much? 20? 5 times 4.
20.
Yes, 20 ohms. It's going to be 20 ohms, which means 5 times 4, 20 ohms. That's how we are going to do it. Because it's 4 times bigger. So that's how we are going. Because if it was in series, you are not going to get it. So R2, you are seeing here, what is R2? 5 ohms. So, yeah. So which means the 5 ohms, since R3 is 4 times bigger, so which means if you know R2, now I want R3, I make it times 4 because R3 is equals to 4 times R2 because it's bigger 4 times. So it will be 4 times 5. What is 4 times 5? Then you write equals to 20 what? 20 ohms. Yes, that's how you do it. So this is the 20 ohms which we are referring to. This is the 20 ohms. If they asked for number R2, the question was asking for only R watt. Calculate the resistance of R2. So this is the only question that they referred to. But once you know the resistance of R2, you can be in a position to calculate the resistance of R3, isn't it?
Yeah.
Yes, by just multiplying. Any question there for 9.21 and 9.22 before we go to 9.3?
Yeah, I only have one question, and
Yes, ask. That's good. That's good. Yeah.
yeah, I just wanted to ask why did you get like the first like properties of the ohms of the different resistors instead of using the like the direct formula to get the number of ohms for R2? Because
Like
we
to get the direct form, like
first,
for explain so that I understand the question.
yeah, we first calculated that the resistance between the parallel circuits is 4. And
Yes,
then,
yes, that's true. Yes, it's 4. Yes.
and then we said that R2 is 0.8, if I recall. Yeah, 0.8 ohms.
Yeah. We disregarded this method. Why? This method only works if R2 and R1 are in series. If these resistors were in series, then that's when we're going to use this method. This one.
Oh, it doesn't work.
If they were in what? If they were in series. But here they are not in what? In series. Here they are not in series. They are in what? These resistors. R2 and R2 are in what?
In parallel.
That's why we used this method, which is 1 over RP. So in other words, this working only works for series.
Oh,
If
yeah.
in series, then this will be the correct working. But because they are not in series, the resistors are in parallel, then that's why we are using 1 over RP, that is the correct method, this one. That's why I showed you that the first method, it only works for the ones in series if they are joined together like this, like that. If they were joined together like that, which means on top of each other, like that. Okay.
Which means that
We are going to do like this, yes. Because the 4 ohms, it means I add this one. They are in series. So it will be 0.8 and 3.2, then I get 4. Okay.
So we calculated
But because the resistors are not in series, they are in what? In parallel. That's why I used the method of working. I used the 1 over RP. Yes. I don't know if your question is answered.
Yeah, it's answered.
It's answered.
Yeah.
Okay. So let's move to 9.3. Let's move to 9.3. A hair dryer operates at a potential difference of 240 volts and the current is 9.5 amps. If it takes Elena 12 minutes to completely dry hair, so which means you are going to use it for 12 minutes, and the ESCOM charges energy usage at 1 rand 47 cents per unit, 1 unit, which means the unit which ESCOM charges is a kilowatt hour, which means kilowatt multiplied by the hour, which is going to use. So calculate the cost of operating the hair dryer for 12 minutes. So this is a very practical problem. You want to know, for using that hair dryer for 12 minutes, how much money have you spent already? So do you have an idea or you need help?
I need help.
You need help. So the first thing, let's convert 12 minutes to hours. Let's convert 12 minutes. Can you see here? 12 minutes. Convert 12 minutes to hours. How many hours is that?
2 hours.
How many hours? So if you are converting 12 minutes to hours, you divide by what?
By 6.
By 60. So how many hours is that? 1/5 hours, which is equals to what?
0.2
0.2 what?
hours.
Hours, which is h, 2.2 hours, h. Okay, that is the time which the person used. Now, so we want to know how many units, how many kilowatt hour did this person use? What is the power of this hair dryer? What is its power? When you operate it for a second, how much power is it using? Power, what did I say about power? The formula for power?
Is equals to A squared times
Yes.
R.
Yes, P is equals to I squared times R, or what is the other formula which I told you? P is equals to what?
V
V times what?
I.
Times I, excellent. V times I. So which means, in this case, I'm not going to use the resistance like what I did on the first question, when I was calculating R1. When I was calculating R1, I'm not going to use this formula. Why? Because I'm given the voltage and I'm given the what? The current. So what it means, which means P is equals to voltage times current. I'm given my voltage. So I substitute. So you'll be saying P is equals to what? P will be equals to the voltage, 240. You write your 240. So it's going to be 240 multiplied by the current. What is the current? 9, what? Current 9,5 amps. Can you see? 9,5 amps. Voltage and current. So let's calculate. Put in a calculator. You tell me what you got. 240 multiplied by 9,5.
2,208.
2,200 and what?
8.
What is the unit? Power.
What?
Watts. Capital letter W. So this is power in watts. So now we want to know how many units is this kilowatt hour? How many kilowatt hour it is? So first, by kilowatt hour, this is in watts. I must convert it to what? To kilowatt, isn't it? How do you convert power to kilowatts? This power to kilowatts. You divide by 1,000. So how many kilowatts is it?
It's 2.28 kilowatts.
Yes, 2.28 kilowatts. That is the power of this appliance, which is the hair dryer. So which means if the hair dryer is consuming 2.28 kilowatts, for how many hours did you use this hair dryer? So which means you are going to multiply by 0.2, isn't it? Yes. So let's calculate how many units did I use. That's what I want to know now, isn't it? So the number of units which I've consumed, units. So here we are calculating now the units which I have used now by using this hair dryer for 12 minutes. So the units are going to be the kilowatts. It's 2, what? 28 multiplied by the hours. How many hours did you use it for? 0, what?
0.2 hours.
Yes. So calculate. What is the final answer?
0.4 456 units,
It's
456.
0.456 units. 0.456. So these units are in kilowatt hour, because you're multiplying kilowatts times the hours, then you got 0.46, but the answer, the units is going to be kilowatt hour, isn't it?
Yeah.
So what is the cost of 0.456 kilowatt hour? If 1 rand, if 1 unit cost 1.47 per unit, and yourself you have used how many units?
0.456 units.
Yes. So 1 unit is just 1 kilowatt hour. That's what it means. So which means I have used for 1 rand 47, how many kilowatt hour is it going to cost? So which means 1 unit, this is per unit. So which means I'm going to multiply that 0.456, multiply by what? 1 rand what?
47.
Yes,
1.47 rand.
Yes, so let's multiply, you see what you are going to get. So 0.46, these are the units that you have consumed. So you 0.456 units that you have consumed, which means this is the cost in rands which you are looking for. You are looking for the cost. So you are going to multiply by the cost of that unit, 147 rands. So what answer are you going to get? It's 1.47 rands. So when you multiply, what is the answer that you are going to get?
0.67 rand.
0.67
rand.
rands. So that is the cost of using the hair dryer for how many minutes? 12 minutes. Yes. Just in summary, we first convert the time, must always be converted to hours. If you are given seconds, convert the time to hours like what we did there. 12 minutes was 0.2 hours. We already converted by dividing by 60. That's what we did there. And also the other issue, you must know how to calculate power. Voltage times what? Times current. You get power.
Yes.
You get your power in what? After you've got your power in watts, you convert to kilowatts, by dividing by 1,000. You divide by 1,000. So now you already have a kilowatt, but you need to calculate to multiply again by a watt, by an hour. The hour which you have used is the hours which you used were 0.2 hours. So 2.28 kilowatts multiplied by 0.2 hour, you get 0.456 kilowatt hour. These are the units that you used yourself. So what is the cost for 1 unit? It's 1.47 rands per kilowatt hour. And myself, I only used 0.456 kilowatt hour. In other words, I did not use the complete unit. It was less than a unit. So that's why my money, which cost, it's less than 1 rand, because it's now 0.67, which is just 67 cents for using a hair dryer for 12 minutes. Any question there?
No, sir. I'm sorted.
I will share the recording on the group and tell other learners also to join. There is a session again tomorrow. So we alternate, maybe today physics, tomorrow chemistry, physics, chemistry, and so on.
Okay.
All right, so our session has come to an end. So I will share the recording. Where you did not understand, you can recap and refresh your memory. So we'll end here for today. Then we'll meet again tomorrow, same time.
No, okay, sir.
All right.
Thank you.
You tell others, grade 10, 11, and 12 to attend online.